In the quiet of our night sky, there is a shadow approaching, a faint blur, so delicate you might mistake it for a trick of the eye. And yet that blur is a titan, an entire galaxy of 1 trillion stars rushing toward us across empty space. Andromeda. To gaze upon it is to glimpse not only a neighbor, but our fate. For in 4 billion years, it will meet the Milky Way. Galaxies will collide, worlds will be scattered, black holes will merge, and in that chaos, a new galaxy will be born. This is not science fiction. This is our future. In the vast silence of the cosmos, there are destinies written not in seconds, not in years, but in billions of years. Some futures arrive like whispers, slow and inevitable, creeping forward without sound. One such future is already in motion, invisible, patient, unstoppable. 4 billion years from now, the night sky above Earth, if Earth still exists, will begin to change. First, a smudge of light will swell into a great arc, then into a luminous cloud stretching from horizon to horizon. And then, in the most titanic collision our galaxy will ever endure, the Milky Way will merge with its nearest neighbor, the Andromeda Galaxy. This is not speculation. This is not science fiction. It is written into the trajectories of stars, etched into the fabric of cosmic motion. Andromeda is falling toward us, pulled by gravity across 2.5 million light-years of emptiness. It races toward us at over 100 kilometers every second. The night sky above our descendants, or perhaps some other species that inherits this planet, will bear witness to the impossible, galaxies colliding, tearing, and rebirthing in fire and starlight. The paradox, of course, is that collisions in space rarely mean impact. Galaxies are mostly empty. Stars, separated by unimaginable distances, will pass each other like ghosts. Our sun may never strike another star. And yet, though the stars will not collide, their gravity will. Whole planetary systems will be thrown into chaos. Stars will be flung from their homes into the void. Others will spiral inward toward the swollen black holes that dwell at the galaxy's hearts. For us, the inhabitants of one spiral arm on one quiet world, the coming collision is more than spectacle. It is fate. It is destiny. We are passengers on a galaxy in motion, our future tied to a cosmic ballet far beyond our control. But to truly understand what awaits, we must step back, beyond the scale of human time, beyond the scale of human history. We must ask a question that feels almost impossible to hold in the mind. What does it mean when galaxies collide? The Milky Way is our home, a spiral of stars 100,000 light-years across, containing hundreds of billions of suns. At its heart, a black hole the size of millions of suns devours matter and radiates in silence. Its arms coil outward, adorned with dust and nebulae where new stars are born. It feels eternal, stable, a structure beyond time. Yet it too is only temporary. Across the gulf of intergalactic space lies Andromeda, our twin. It is larger, heavier, and approaching, for now it appears to us as a faint smudge, visible only in the darkest skies, a reminder of scale and distance. But that smudge hides a titan, 1 trillion stars, vast clouds of gas, and a central black hole that hungers like our own. The collision is already decided. Like two ships drawn toward one another by unseen tides, the galaxies will meet. And when they do, the universe will not pause. It will not spare us. It will proceed with its own vast indifference. For civilizations such as ours, newly born and fragile, the inevitability of such a future is humbling. Our empires, our histories, our achievements are measured in centuries, in millennia at most. Compared to the lifespan of a galaxy, they vanish like sparks in the wind. Yet in this fleeting moment of awareness, we have discovered what lies ahead. We can peer billions of years into the future and witness the destiny of our galaxy. We know the end of the Milky Way not as myth, not as prophecy, but as fact. This knowledge transforms the night sky. Every time we look toward Andromeda, we are staring not at a distant neighbor, but at our future. That faint light is not only what is, it is what will be. The collision is already underway, though it will take billions of years to complete. We are already bound to Andromeda by invisible chains of gravity. And here lies the first riddle. Why do galaxies collide at all? The universe is expanding. Space itself stretches, pulling galaxies apart, scattering them into the dark. And yet, Andromeda falls toward us. The answer lies in gravity's patient hand. Within our local group, expansion yields to attraction. The Milky Way and Andromeda are bound together, caught in each other's pull. The larger universe may fly apart, but here, in this tiny corner of creation, collapse is the only future. Imagine the Earth 4 billion years from now. The sun, swollen into a red giant, scorches the skies. If Earth survives its fire, the heavens above will glow with Andromeda's encroaching form. No longer a smudge, no longer faint. A sprawling alien swirl of light and shadow that transforms the familiar constellations into a tapestry of chaos. It will be beautiful. It will be terrifying. And as the galaxies entwine, as stars bend and arcs of gas ignite in new bursts of creation, one question will echo across the abyss. Does anything endure? What happens to the fragile worlds, the brief lives, the civilizations that dare to rise in the shadows of colliding giants? The story of Andromeda is not only the story of astronomy, it is the story of impermanence, written on the largest scales. Galaxies are not eternal. They are born, they live, they collide, and they die. And we, bound to them, share their fate. This is the beginning of our journey, a voyage into inevitability, into the strange, dark future that awaits us. The Milky Way's fate is sealed. Andromeda approaches. The silent collision has already begun. We live inside a structure so vast, the mind retreats from its scale. This is our address in celestial shorthand. A rocky planet circling a yellow star, 26,000 light-years from the center of a barred spiral called the Milky Way. Our star completes one orbit in roughly 230 million years, a single galactic year. We have not made many of them. All of human history fits inside a sliver of our current lap, a brief spark in one turn around the core. From the outside, the Milky Way would resemble a whirlpool, a central bar, grand spiral arms laced with cold gas and newborn stars, and a dimmer spray of older suns forming a thickened disk. Threaded through it all is something we cannot see directly, yet whose gravity holds the galaxy together, a halo of dark matter far larger than the disk of starlight. Within that invisible scaffolding orbit hundreds of billions of suns. Numbers fail to carry the truth. Every dot is a system, every system a weather of worlds, many barren, some broken, some perhaps briefly lit by life. Our local sky bears the imprint of this architecture. The sun is a citizen of the Orion Arm, a minor spur between two grander rivers of starlight, Perseus and Sagittarius. We drift inside a cavity carved by ancient supernovae, 1,000 light-years wide, the interstellar medium here thinned and warmed by vanished catastrophes. The constellations we trace are parochial, patterns on the inside wall of a cathedral we cannot yet step outside to see. Even so, the cathedral leaves its marks, dark lanes of dust vaulting the Milky Way's band, star nurseries glowing in pink and blue, clusters like spilled salt along the arm. At the center sleeps a black hole 4 million times the mass of the sun, wrapped in a cloak of stars whipping around it at relativistic speed. We call it Sagittarius A star. It is no constant devourer, but a patient engine, flaring when a stray cloud strays too close. Around that well, the entire disk turns, stars and gas participating in a choreography older than life on Earth. Our velocity in this dance, about 220 kilometers per second, makes no wind in our faces. Space offers no air to feel our speed. We move through the dark as a fish through still water, swift and unaware. We are small, but not insignificant. The chemistry of our bodies is written in the supernovae that seeded this spiral with heavy elements. Iron in the blood, calcium in the bones, carbon in every thought, all exhaled by dying stars that returned their cores to the medium, which in time condensed again into clouds, into suns, into worlds, into observers. To know our place is to feel history not as a line but as a cycle. Matter passing through furnaces and frost until awareness arises to contemplate its own origin and fate. From within the disk, the galaxy appears as a bright band, but radio and infrared eyes reveal its skeleton. Long filaments of hydrogen braid the arms, giant molecular clouds collapse under their own gravity, igniting clusters that drift like lanterns before dissolving into the field. Globular clusters, older and tighter, hover in the halo like fossilized swarms, each containing hundreds of thousands of ancient suns. They are time capsules, reminders that the Milky Way has been forging stars for more than 10 billion years, through seasons of plenty and seasons of silence. Our position tells a quieter story about danger and refuge. We are not near the jammed heart, where radiation and tides are cruel, nor in the sparse outskirts, where star formation dwindles and heavy elements are scarce. We orbit in a temperate suburb, a Goldilocks swath of the disk, where supernovas occur but do not scour the sky with unbearable frequency, where metallicity was high enough to build rocky worlds, where time was long enough for chemistry to try, fail, and try again. If life is a long experiment, our neighborhood gave it room to run. Rise above the plane in imagination and watch the sun's path against the disk. You would see a rosette, a slow epicycle superposed on the main orbit, our system bobbing above and below the midplane like a leaf on a long swell. This vertical oscillation carries us through denser and sparser layers of dust and gas over tens of millions of years. Some suspect these passages help shake comets from distant reservoirs, a reminder that celestial mechanics whispers into the chronicles of oceans and stone, and that the Milky Way's tides reach quietly into the history of life. To speak of our place is also to admit how provisional our maps remain. We chart the arms by parallax and standard candles, by pulsar timing and the dimming of starlight through dust. Missions like Gaia trace the motions of more than 1 billion stars, revealing ripples in the disk, memory waves from past encounters. The galaxy keeps minutes of every meeting, streams arcing through the halo, the ghostly remnants of dwarf galaxies consumed long ago. In those minutes is written a truth that steadies as it unsettles. The Milky Way is not a static pinwheel, but a living record of tides, accretions, and scars. Even with such revelations, we are still cave painters before an unlit wall. We cannot step far enough away to see our spiral hole. We infer its shape from within, reading pressure lines in the air. We share this disk with satellite galaxies and rivers of stars torn from them. Our dark halo stretches beyond the bright disk, a sphere of influence the eye cannot trace. And beyond that halo, another titan waits. Look toward the faint smear in the northern sky, in the constellation Andromeda. To the naked eye, under dark conditions, it is only a ghost. Through a telescope, it becomes a city of suns. In radio and infrared, it is a storm of gas and gravity, falling toward us across the void. Even now, its motion writes itself into the spectral lines we measure, a steady blue shift, modest in the instant, decisive over aeons. The neighbor is not merely nearby, it is inbound. What does it mean to be a creature who can know this? To live a life counted in decades and still perceive a destiny measured in billions of years? Perhaps this is our inheritance, to be small and aware, and to build instruments that extend our senses until the galaxy becomes legible. We cannot choose the stage on which we were placed. We can choose how to look across it and how to tell what we see without flinching from scale or time. We have found our seat in the amphitheater. In the next act, we will learn that the amphitheater itself is moving, that the neighboring balcony drifts toward ours, that the architecture of the hall ensures a meeting. Our place is no longer merely a coordinate in a spiral. It is a trajectory. It is a rendezvous. The drift toward Andromeda has begun. The question is not whether it comes, nor even precisely when, that we will reckon with, but what such a meeting does to homes like ours, to suns like ours, to worlds that have just learned their address. Between the Milky Way and Andromeda lies a void so vast it silences language. 2.5 million light-years of blackness stretch between the spirals, a gulf wider than imagination allows. Yet across that abyss, something unstoppable unfolds. The galaxies are not fixed islands. They are drawn together, their motion dictated by gravity's quiet hand. This is the local group, our small cluster of galaxies adrift in a universe of 100 billion others. The local group is modest compared to sprawling superclusters, yet within it, two giants dominate, the Milky Way and Andromeda. Smaller companions, Triangulum, the Magellanic Clouds, a swarm of dwarfs, circle around them, like sparks cast from colliding logs. All of them are bound within a greater invisible envelope, a shared halo of dark matter. It is this hidden mass, this unseen scaffold, that ensures the meeting of titans. At first glance, such a union seems paradoxical. The cosmos is expanding. Galaxies on large scales recede from one another, carried outward on the tide of space itself. The more distant the galaxy, the faster it flees. So why should Andromeda fall toward us instead of away? The answer lies in proximity and mass. Within the local group, gravity overpowers expansion. The Milky Way and Andromeda sit too close, with too much mass, to drift apart. They are caught in each other's embrace, falling inward through time. The universe may stretch endlessly, but here, collapse is destiny. Andromeda approaches at 110 kilometers per second. Each second it closes by the length of a small country, every hour by the distance to the moon, every day by tens of millions of kilometers. Yet such speeds are glacial when measured against the abyss. At this pace, the final meeting still waits billions of years. To us, it is imperceptible. To the universe, it is already underway. How do we know this? The light of Andromeda carries the truth. Spread its glow through a prism, and its spectral lines are shifted toward blue. Unlike most galaxies, whose light stretches red as they recede, Andromeda's shortens, a sign of approach. Astronomers first noticed this more than a century ago. At the time, it was an anomaly, a curiosity. Today, it is a prophecy. Andromeda's light tells us not only where it is, but where it is going. It is a message from the future, written in the language of starlight. Our instruments refine the message further. The Hubble Space Telescope tracked the subtle sideways drift of Andromeda's core against the distant background. With patience, astronomers traced its trajectory, confirming that the galaxy is not merely brushing past, but aimed straight at us. Not a near miss, a collision course. And so the long drift continues, silent, unstoppable, a 4 billion-year journey into inevitability. We live not in a stable cosmos, but in one where galaxies dance, collide, and merge in an endless cycle. What seems permanent is only temporary. The spiral arms of the Milky Way, familiar and grand, are already doomed to distortion. Pause for a moment to imagine the enormity of the scales involved. Every star in the Milky Way moves in its own orbit around the galactic center. So too does every star in Andromeda. Each of these billions of suns traces a path determined by the pull of billions of others. The galaxies are not rigid objects, but swarms, clouds of stars held loosely in shape. As they approach, their swarms will interact, not through direct collisions, but through tides, The gravitational fields will stretch, bend, and warp them like liquid sculptures.
The drift is not uniform. Our dark halos may already be overlapping, ghostly spheres colliding long before the visible disks meet. Dark matter interacts only through gravity, yet its influence extends far beyond the stars we see. If we could map the invisible, we might discover the first stages of union are already happening. We are already entangled with Andromeda, stitched together by unseen filaments.
What does such knowledge mean to us, tiny observers with lifespans measured in decades? It means we live in a universe not built for permanence. The galaxies themselves, vast beyond reckoning, are travelers like us, subject to change, to fate, to eventual dissolution. To watch the drift toward Andromeda is to confront the impermanence of all things, written on the largest possible canvas. Yet there is wonder here too. Without collisions, galaxies would starve. The intermingling of gas clouds in these cosmic meetings triggers new waves of starbirth, igniting fresh generations of suns. The long drift toward Andromeda is not only an omen of destruction but a promise of renewal. Stars not yet born will blaze into life because of this union. Worlds not yet formed may circle them. Life not yet imagined may gaze upon their skies. We measure time in years, but the galaxies move in epochs. They are patient. We will not see the first distortions in our lifetimes, or in 1,000 lifetimes, or even in the entire span of humanity's existence. Yet the knowledge of the collision changes us. It reshapes how we see the sky. That faint blur of light in Andromeda is not merely a neighbor. It is the future. To look at it is to look forward billions of years, to witness destiny advancing, slowly but without pause. Perhaps the strangest truth of all is this. While the drift appears unstoppable, the outcome remains unpredictable in detail. Galaxies are too vast, too chaotic, too filled with billions of moving pieces to forecast precisely. Simulations show many possibilities, multiple passes before merger, tidal tails of stars cast into the void, even the chance that the triangulum galaxy joins the dance. The future is written in broad strokes, collision, merger, transformation, but the details remain a blur of probabilities. Even on this scale, uncertainty reigns, and so the long drift continues. The Milky Way sails through its orbit, dragging its spiral arms like vast rivers of light. Andromeda, larger and more massive, falls toward us, its stars unaware, its worlds oblivious. For billions of years, the two galaxies will circle closer, their shapes bending, their fates entwining. What will it look like when the first tendrils of Andromeda brush against our sky? When its spiral arms loom across the horizon, vast enough to rival the moon? What would it feel like to stand beneath such a sky, to witness beauty on the scale of apocalypse? The drift has begun, the stage is set, and soon, in cosmic terms, the first act of collision will arrive. The cosmos does not speak in human words. It whispers in photons. Every star, every galaxy, every cloud of gas casts its story outward as light. For most of human history, we looked at that light and saw only brightness. The shimmer of the stars, the hazy arc of the Milky Way, the faint blur of Andromeda. Beauty, but not meaning. It was only when we learned to read the hidden script within light that the future of our galaxy was revealed. Andromeda has always been there, lurking in the dark skies above the northern hemisphere. To the naked eye, it appears as a pale smudge in the constellation of the chained princess, Andromeda. Ancient astronomers catalogued it as a nebula, a faint cloud. The true nature of this ghost remained veiled for centuries. Was it a nearby swirl of gas within our Milky Way, or a universe in its own right, far beyond? The answer to that question, deciphered only in the 20th century, reshaped our place in the cosmos. But even before the debate was settled, a clue lay hidden in its glow. When you spread light through a prism or through the slit of a spectrograph, you do not merely reveal color. You reveal fingerprints, absorption lines cut through the spectrum, each one a mark of an element: hydrogen, helium, sodium, iron. The stars tell us their composition through these dark notches. They also tell us something more: motion. Thanks to the Doppler effect, light stretches or compresses depending on whether its source is moving away or toward us. A galaxy retreating into the expansion of the universe leaves its lines shifted toward red. A galaxy rushing closer shifts them toward blue. Most of the heavens are red. Andromeda is not. Its light is blue shifted. The message is stark. It is coming. In the early 20th century, astronomer Vesto Slipher was among the first to detect these shifts. He trained his telescope and spectrograph on nebulae across the sky and found most were receding, stretched by cosmic expansion. Andromeda, however, was moving the other way. Its lines marched toward the blue. Slipher recorded its speed, hundreds of thousands of miles per hour. It was an anomaly, a contradiction. While the universe expanded, Andromeda fell inward. At the time, the meaning was not yet clear. Astronomers had not even agreed on what Andromeda was. That answer came later through the work of Edwin Hubble. By identifying Cepheid variable stars within Andromeda, Hubble measured its distance, millions of light-years away, far beyond the edge of the Milky Way. It was not a gas cloud. It was another galaxy, another island universe. And it was falling toward us. The revelation was staggering. For the first time, humanity understood the scale of the cosmos. The Milky Way was not alone. The sky was filled with galaxies, each vast and distant, and among them, Andromeda was special, not because of its beauty, but because of its trajectory. It was on a collision course. Decades passed, and instruments sharpened. The Doppler shift told us Andromeda's line-of-sight speed, but not its sideways motion. Was it aimed directly at us, or would it pass by, grazing instead of colliding? For years, this uncertainty lingered. The future seemed ambiguous. Then came the Hubble Space Telescope, orbiting high above Earth's atmosphere, watching with unblinking precision. Over years, then decades, Hubble tracked the tiny motions of Andromeda's stars against the fixed backdrop of quasars. The drift was minute, fractions of a milliarc second, but enough. The verdict was inescapable. Andromeda was not veering away. It was aimed directly at us. This was the moment speculation became certainty. The Milky Way and Andromeda would meet. The only question left was when. Simulations followed, running on the world's most powerful supercomputers. Galaxies of billions of stars were recreated in digital form, their masses, velocities, and dark matter halos set in motion. The future played out at accelerated speed, two great spirals drifting together, passing once, twice, then coalescing into a single swollen remnant. Some simulations showed a first contact in 4 billion years, with full merger by 6. Others varied, but the essence was unchanged. The Milky Way, as we know it, is temporary. The future is written not in myth, not in prophecy, but in light. Photons that left Andromeda 2.5 million years ago have delivered the message. Every spectrum we capture confirms it. The trajectory is sealed. What does it mean to hold such knowledge? Humanity will not exist to witness the collision. Our species, if it endures, will be changed beyond recognition by then. Earth itself may not survive the sun's expansion into a red giant, which will scorch its surface long before the galaxies meet. Yet here we are, at the dawn of awareness, able to know a fate that lies billions of years ahead. There is humility in this. To see beyond the span of our lives, beyond the span of our species, is to confront the scale of the universe. We are creatures of decades who can glimpse the future of galaxies. We are temporary, but our vision stretches across epochs. The light of Andromeda teaches us not only where we are, but when we are. Early passengers on a voyage whose climax lies aeons away. And in that knowledge lies awe. For the night sky is no longer static. It is alive with trajectories, with futures encoded in motion. The constellations we see are not permanent. Orion's belt will scatter, the Big Dipper will twist. And beyond them all, Andromeda approaches, slow but inevitable, a ghost of the future already rising in the present. The future of our galaxy has been written in light. We have read it. The only question that remains is what will happen when the writing becomes reality. And so we stand on the threshold of inevitability. We know the collision is coming. The night sky itself will become a prophecy fulfilled. The next step in our journey is to ask, what happens when two galaxies meet? Before we can imagine two galaxies colliding, we must first understand what a galaxy is. The word itself, galaxy, comes from the Greek galaxias kyklos, the milky circle, the band of pale light across the night sky. For millennia, it was only a blur, a riddle of light. Today we know that blur is a vast spiral of stars, gas and dust. But a galaxy is more than what we see. It is a structure layered with secrets. To picture the Milky Way is to picture motion. Our galaxy is not static. It is a dynamic, restless swarm. Hundreds of billions of stars orbit its center, each on its own path, moving through gravity's invisible net. Like bees in a hive, they form a collective pattern, a spiral, but no single star knows the pattern. The spiral is an emergent shape, a wave written in the orbits of suns. A galaxy is not solid. Between the stars lies emptiness, so much emptiness that if the sun were shrunk to the size of a coin, the nearest star would lie thousands of kilometers away. A galaxy's grandeur comes not from density but from scale. So much space filled with so many stars that the eye sees a river where the truth is a desert scattered with sparks. The Milky Way's visible body spans 100,000 light years. Within its arms, stars form in nurseries of gas and dust, giant molecular clouds where gravity gathers atoms into clumps, ignites nuclear fires, and scatters newborn suns into the spiral. Here, stars live and die, creating the next generation of elements: carbon, oxygen, iron. Every atom in our bodies was forged in these furnaces. A galaxy is a factory of stars and, by extension, of life. At its heart lies something darker. 4 million solar masses compressed into a single point, a supermassive black hole, Sagittarius A star, silent most of the time, but capable of flaring when it swallows an unlucky star or cloud. For years, astronomers thought black holes were exotic, rare. Now we know every large galaxy harbors one at its core. These monsters anchor the swarms of stars around them, and when galaxies collide, their black holes spiral together in a final dance, radiating waves that ripple across the fabric of space-time. Surrounding the Milky Way is a halo, spherical, faint, and ancient. It holds globular clusters, dense knots of stars older than the disk, fossils of the galaxy's youth. Some contain stars formed only a few 100 million years after the Big Bang. They are time machines, reminders that galaxies are not born whole, but assembled piece by piece through collisions with smaller companions. Our galaxy, like every galaxy, is the product of cannibalism. The halo is littered with stellar streams, the shredded remains of dwarfs the Milky Way consumed long ago. Beyond even the halo lies a mystery greater still: dark matter. Though invisible, it outweighs the stars by a factor of 5. It is the scaffolding, the hidden mass that prevents galaxies from flying apart. Without it, spirals would unravel. Without it, no galaxy would exist. We cannot see it, cannot touch it, but we feel its gravity in every orbit, every rotation curve. To understand galaxies is to accept that most of their substance is unseen. The Andromeda Galaxy, larger than our own, mirrors this anatomy. A grand spiral 200,000 light-years wide, its disk brims with dust lanes and star clusters, its core glows with an older population of stars. It too hides a supermassive black hole, larger than Sagittarius A star. It too swims in a halo of dark matter. It too is haunted by streams and scars, evidence of smaller galaxies devoured. We imagine galaxies as permanent forms, majestic and serene. But they are fragile. The spiral arms are transient patterns, density waves that shift over time. The disks can warp, buckle, and tear under tidal forces. Even their halos are porous, bleeding stars into intergalactic space. A galaxy is not an immutable island. It is a storm that can be reshaped by another storm passing through. Collisions are common. In deep space surveys, we see galaxies torn in half, arms flung like ribbons into the void, cores collapsing into knots of fire. Some mergers are graceful, spirals combining into swollen ellipses. Others are violent, birthing quasars and starbursts that blaze like beacons across the cosmos. Each galaxy carries the memory of collisions past. The Milky Way has consumed dozens. Andromeda has too. Their next meeting will be the most dramatic, but not the first. And so, when we imagine the fate of our galaxy, we must strip away the illusion of permanence. The Milky Way is not eternal. Its anatomy is fluid. Its spiral arms, its disk, its halo, all will be stretched, twisted, and absorbed. The features we take for granted are only chapters. Soon they will be rewritten. Yet there is a paradox in this fragility. Galaxies are fragile, but they are also resilient. Their stars almost never collide directly. The void between them protects them. The black holes at their cores may merge, but most suns, most worlds, continue on new orbits, indifferent to the chaos. A galaxy changes shape, but the stars endure. The anatomy shifts, but the matter remains. This duality, fragility and endurance, is what makes the coming collision so haunting. The Milky Way and Andromeda will both be destroyed and reborn. Their spirals will vanish, their identities erased, but their stars will live on inside a new structure. A swollen elliptical, a cosmic chrysalis, born from the death of two spirals. If you were to stand on a planet orbiting a star in Andromeda, you would see your own galaxy as a faint smudge in the night. You would wonder at its glow, measure its distance, and perhaps, as we have done, realize it was falling toward you. You would not know that your home too was fragile, that its anatomy was temporary, that its fate was already sealed. Galaxies are not eternal. They are stories written in stars, told across billions of years, and like all stories, they change, they merge, they end. The Milky Way's anatomy, its graceful spiral arms, its glowing heart, its fragile disk, these are the opening chapters. The ending is still to come, and the next page is Andromeda. The collision between the Milky Way and Andromeda is not a sudden crash. It is a dance, a long, slow spiral that unfolds over billions of years, choreographed not by chance, but by gravity. The galaxies are not rigid disks, not monolithic wheels of stars. They are fluid, malleable swarms, drawn into motion by each other's pull. When they first meet, they will not shatter in an instant. They will circle, entwine, and orbit one another like partners locked in a cosmic embrace, each pass reshaping them more deeply until they can no longer remain separate. This dance has already begun, though at a distance we cannot yet perceive. Invisible tides are tugging faintly on the outskirts of both galaxies, shifting halos of dark matter that overlap like ghostly spheres. The stars within these halos may already be responding, falling into new orbits, feeling the approach of an unseen neighbor. What we call the future collision is not a moment, it is a process, long and inexorable. Imagine the first true approach. 4 billion years from now, Andromeda looms large in the night sky. Its delicate spiral fills a swath of the heavens, rivaling and then dwarfing the Milky Way's own river of light. Slowly, silently, The disks draw closer until their edges overlap. Yet instead of smashing together, the galaxies pass through one another, stars gliding by with miles of emptiness to spare. For most suns, it is a near miss, not a collision. But gravity remembers. The encounter leaves scars. The elegant spirals will not survive their first pass. Gravitational tides will stretch them, pulling long tails of stars and gas into the void. Vast arcs of light will stream away like ribbons, bridges of stars connecting the galaxies even as they drift apart from their first embrace. Within their disks, clouds of gas will collide, compressed into dense knots that ignite with fire. Whole constellations of newborn stars will blaze into life, the galaxies lit with the fever of creation. And then, after the first passage, the dance tightens. Andromeda will not escape. The galaxies will slow, turn, and fall back toward each other. A second pass follows, closer, more violent. Again, they will tear streams of stars from one another, flinging them into intergalactic space. Some stars will be ejected entirely, cast adrift as intergalactic wanderers. Others will be pulled into great arcs that swing around the merging pair. Slowly, each pass draws them closer until the two galaxies cannot disentangle. From a distance, this process would appear almost serene. In simulations, the galaxies drift together, overlap, and merge in balletic slow motion. But for those within, the sky transforms into chaos. Planets may find their suns tugged into new orbits. Entire solar systems may be displaced, pulled outward into tidal streams or inward toward the core. Some will be flung into exile, carried beyond the safety of a galactic disk into the cold silence of the void. For any inhabitants who endure, the night sky will be a vision of beauty and terror. Arcs of stars across the heavens, veils of dust lit by new suns, spirals unraveling into threads. It is tempting to think of collision as destruction, but the truth is stranger. Galaxies are not broken, they are transformed. The spiral arms, once so orderly, dissolve into streams. The cores, once distant, spiral toward one another. After billions of years of circling, weaving, and tearing, the two giants settle into one body. The dance ends not with chaos, but with stillness, a single swollen galaxy, rounder, redder, quieter than the spirals that came before. We have seen this process across the sky. Telescopes capture galaxies in various stages of collision. Some resemble butterflies with glowing wings of stars. Others show tidal tails stretching hundreds of thousands of light years. We watch these distant collisions as though gazing into mirrors of our own future. Each one whispers, "This is what awaits you. The dance is universal. No spiral survives forever." At the heart of this dance lies something darker still. Both galaxies harbor supermassive black holes. As their hosts entwine, so too will these monsters. At first, they circle distantly, tugging stars into tighter orbits, slinging some away at nearly light speed. Over time, they spiral inward, losing energy as they stir the surrounding matter. When at last they meet, they will merge in an instant, unleashing gravitational waves that ripple across the cosmos. To any civilization with instruments vast enough to hear, the universe itself will shudder with their union. And yet even this violence is not the end. The stars will continue their orbits, the galaxies their merger. New structures will form, rings, streams, shells of stars layered around the new core. Over billions of years, the chaos will settle. The dance will end in equilibrium. The Milky Way and Andromeda will be no more. In their place will stand a new creation, a massive elliptical galaxy astronomers call Milkomeda. But in the time between first touch and final union, the sky above any surviving world will be unlike anything imagined. Nights lit with strange arcs of light, double galaxies looming overhead, nebulas ignited by collision, painting the heavens with fire. To live through such epochs would be to live in a sky that never rests, a sky forever in motion. And perhaps the most haunting truth of all is this: the dance is not rare. Across the universe, galaxies collide every day. We are not unique in our fate. We are simply next in line. For us, the collision is a story of the distant future, billions of years beyond our reach. But for the universe, it is ordinary. The dance before the impact is as natural as sunrise, as inevitable as entropy. Galaxies are meant to meet, to merge, to transform, and so we wait. The Milky Way spins on, carrying its stars, its worlds, its observers, ever closer to its partner. Andromeda approaches. The dance begins in silence. And when it ends, nothing will remain unchanged. The question is not whether the galaxies will dance, but how many steps they will take before the final embrace. And when they do, what will become of the fragile worlds caught between their arms? The first true collision will not announce itself with noise. There is no sound in the vacuum between stars, no thunder across the interstellar void. Instead, it will arrive in silence, an unhurried convergence that unfolds over millions of years. From a vantage point within the Milky Way, it will begin as a change in the sky. At first, Andromeda will appear as a faint spiral, larger each night, luminous enough to rival the moon. Then it will swell until its disk fills the heavens, its arms stretching from horizon to horizon. The stars we know, the constellations we trace, will be overwhelmed by its glow. Imagine standing on a world circling a sun like ours, looking upward to find another galaxy crossing the sky, not as a distant smudge, but as a presence, bright, intricate, immense, a sky filled with two galaxies at once. And then, in a span of millions of years, a mere heartbeat in cosmic time, their edges will overlap. The first contact, spiral arms brushing past one another, gas clouds colliding, stars pulled into distorted streams. It will not be a single instant, not a crash like worlds shattering, but a drawn-out entanglement, a slow violence measured across aeons. Yet to those who could witness it, the transformation would feel sudden, overwhelming, terrifyingly beautiful. The galaxies will not pass through unscathed. Their gravitational tides will reach across space like invisible hands, distorting and stretching their delicate forms. Great arcs of stars will be pulled outward into tidal tails, ribbons of light, tens of thousands of light-years long, flung into the void like cosmic streamers. Whole clusters will be ejected, torn from their orbits, left adrift between the merging giants. Within the disks, where gas is thickest, collisions will be far less forgiving. Clouds of hydrogen that once drifted gently will slam together, compressing into knots dense enough to ignite bursts of star formation. The galaxies will blaze with young hot stars, blue and brilliant, burning their fuel in a few million years before collapsing into supernova. For a brief epoch, the heavens will be alive with fire, an era of creation born from destruction. Yet amid this chaos, most stars will pass each other untouched. The distances are too vast. Our sun, if it survives to this age, may slip through unscathed, its planets still bound in orbit. But their paths may shift. Earth could be drawn outward into a wider track, or inward toward the galactic center. It might even be slung free, cast adrift into intergalactic space, a rogue world carrying the last traces of its life into eternal night. From such a world, the sky would be unimaginable. No longer a tranquil canopy of familiar constellations, but a storm of light, double spirals tearing across the heavens, tidal streams arching overhead, new stars igniting like sparks. The sky itself would become alien, changing within the lifetime of a species, shifting from familiar to unrecognizable. The first contact will also awaken the monsters at each galaxy's heart. The supermassive black holes, still distant, will begin to feel one another's gravity. For now they circle separately, but the streams of matter disturbed by the collision may funnel gas into their maws. They could flare with renewed hunger, blazing as quasars that outshine their host galaxies. For any who gaze upon them, the night would burn with the light of annihilation. But the black holes are patient. Their true dance lies further in the future. For now, the drama belongs to the stars, to the arcs and bridges forming as the galaxies weave through one another. After their first pass, they will drift apart again, as though the collision were a near miss. But appearances deceive. The pull of gravity ensures their paths are bound. They will turn, fall back together, and collide again. Each passage will tighten the embrace until separation is no longer possible. To us who live in centuries, the first contact is an event beyond reach, too far to fear, too vast to witness. And yet the knowledge of it shapes how we see ourselves. For when we look into the night and trace Andromeda's glow, we are not looking at the present. We are looking at an inevitability written in the stars. That faint smear is not merely a neighbor, it is our future rushing toward us in silence. Perhaps the most haunting truth of this first contact is that it is both catastrophic and creative. Galaxies do not merely die in collisions, they transform. Spirals unravel, but in their destruction new stars are born. Planets may be ejected, but others may form around newborn suns. Life may end in some corners, but in others, it may begin. The universe writes its story in cycles, and the collision of galaxies is one of its greatest chapters. The first contact between the Milky Way and Andromeda will mark the beginning of the end for both. Their spirals will never recover. Their delicate arms, carved by density waves and starbirth, will stretch and dissolve. Their identities will blur, becoming fragments of a larger whole. Yet what begins in destruction ends in creation. A new galaxy will rise from the ashes of the old. For now, the Milky Way spins serenely, its stars tracing ancient orbits, its arms winding gracefully. Andromeda drifts toward us, faint and distant, but the future is certain. The first contact will come. The night sky will blaze with unfamiliar light, and when it does, we will no longer be the Milky Way. We will be something else, something new, something born of collision. The question that lingers is this: when the galaxies first touch, what becomes of us, of our star, our world, our fragile spark of awareness? Will we endure the storm or vanish into the silence? Imagine standing beneath the heavens 4 billion years from now. The constellations once familiar no longer align. Orion's belt has drifted apart. The Big Dipper has twisted, its handle stretched into something unrecognizable. Stars have moved across the sky like ships drifting slowly over a black ocean. To the eyes of any survivors, or perhaps to the eyes of creatures that have yet to evolve, the night is already alien. But this is only the beginning, for above the horizon, a new shape swells, Andromeda. No longer a faint smear, no longer a ghost. It fills the sky with its spiral arms glowing brighter than the moon, a cosmic pinwheel that dwarfs every constellation. Its disk stretches from horizon to horizon, a tapestry of stars so dense it paints the heavens with light. To look upon it is to see not a foreign sky, but the future itself bearing down. As the galaxies draw closer, the night becomes stranger still. Long arcs of stars are pulled from their homes, tidal streams that cross the heavens like rivers of fire. Where once the Milky Way formed a narrow band, now the sky is streaked with bridges of light connecting two galaxies, luminous scars left by gravity's hand. Worlds orbiting suns within these streams will find their skies utterly transformed. Nights will glow with unfamiliar constellations, thousands of new stars appearing where once there was emptiness. Then comes the starburst. Collisions of gas clouds trigger waves of creation. New stars ignite in clusters, blazing hot and blue. These newborn suns outshine their elders, flooding the sky with brilliance. To any who watch, the heavens will be alive with fire, an age of creation unfolding overhead, more dazzling than any myth. The night will never again be dark.
And yet the strangeness is not only beautiful, it is unsettling, for amid the glory lies chaos. Planets may find their suns tugged into new paths, their orbits stretched or broken. Some may be cast outward, flung into the void. Others may drift inward, toward the galaxy's swelling core. For those who endure, the sky will tell the story, a vision of grandeur laced with dread.
The familiar rhythms of the heavens will vanish. No longer will the constellations return with each season. The great arcs of tidal light will shift from one lifetime to the next. For the first time, a species could witness the slow evolution of a galaxy, not through instruments but with the naked eye. The sky itself will be alive, moving, changing. Every generation will inherit a different night. And then, as Andromeda's core draws near, the strangeness deepens. Two galactic centers rise in the sky, glowing with the collective light of billions of stars. They loom like twin suns, not bright enough to cast shadows, but brilliant enough to dominate the night. For those who look upward, the heavens will feel heavy, burdened with giants. From such a world, the night sky will seem less like a dome and more like a battlefield. Streams of stars arc overhead, new suns blaze into life, black clouds of dust shroud whole regions of light, glowing faintly as they are torn apart. The familiar is gone. The sky itself has become alien. And yet, amid the strangeness, there is beauty beyond comprehension. No painting, no myth, no vision in the history of humankind could match the spectacle of two galaxies entwining above a world. The night will be a canvas of fire and shadow, arcs and spirals, chaos and creation. For any eyes that endure to see it, the sky will be a cathedral of awe. But with awe comes a question. What is it to live beneath such a sky? To know that your world is caught in a collision so vast it defies imagination? Would such beings see themselves as fortunate, witnesses to cosmic grandeur, or as doomed, trapped in the slow violence of colliding giants? The night sky, once a comfort, would become a reminder of fate. The strangeness of the heavens will last for billions of years. With each passage, the galaxies will draw closer, their shapes dissolving further. Spirals unravel into threads, threads into clouds, clouds into a swollen core. By the end, no arms will remain, no familiar disk, no Milky Way, no Andromeda. Only a single round galaxy, quiet and red, the product of destruction and creation. But in that long journey, the night sky will bear witness to every stage. From the first faint swelling of Andromeda's glow, to the arcs of stars crossing overhead, to the double cores looming above, to the final stillness. The heavens will be strange, and yet they will tell the truth. They will reveal, in light and shadow, the story of transformation. And for us, here and now, to imagine that strangeness is to glimpse not only the future of the sky, but the fate of all things. Nothing remains the same, not the constellations, not the galaxies, not even the stars themselves. Everything shifts, everything changes, everything ends. The night sky will turn strange, and in its strangeness it will reveal the most profound truth of all, that beauty and destruction are not opposites but partners, that creation is born from collision, that the universe does not preserve but transforms. The question that remains is this: when the sky becomes unrecognizable, will we endure to see it, or will we vanish long before the heavens turn strange? When galaxies collide, it is tempting to imagine apocalypse, stars smashing into stars, worlds splintering under the impact of suns. But the reality is stranger, more subtle and more haunting. For the stars themselves are small compared to the gulfs between them. The chance of one sun striking another is almost non-existent. Yet the fates of their planets are not so secure. The true danger lies not in collisions, but in gravitational tides, forces that can tear orbits apart, exile worlds into the void, or drag them into death. And so we turn to the question most immediate to us. What will become of our star, our Earth, our solar system, when the Milky Way and Andromeda first touch? The Sun is not immortal. Long before the galaxies fully merge, its own clock will have nearly run down. In about 5 billion years, it will exhaust the hydrogen in its core. Its heart will contract, its outer layers will swell, and it will become a red giant. Mercury and Venus will be consumed. Earth may be engulfed or spared only to be scorched and stripped of atmosphere. Long before the galaxies have fused, our world will already be dead. But the solar system itself may still exist as a husk, circling the fading sun as it sheds its outer layers into space. By the time the Milky Way and Andromeda are fully entwined, the sun will have become a white dwarf, an ember of what it once was, glowing faintly in the dark. If Earth survives the red giant phase, it will orbit that ember, a frozen relic, a world long abandoned by life. Yet even this husk is not secure. As the galaxies merge, the sun's orbit around the galactic center will be pulled into new paths. Our system may be thrown into a different orbit entirely, flung outward into the galactic halo or inward toward the core. The probabilities are uncertain, but the possibilities are profound. There is a chance the solar system will be ejected altogether. In the chaos of the merger, some stars will be accelerated by gravitational slingshots, cast free of the new galaxy entirely. They will wander as galactic exiles, rogue stars adrift in intergalactic night. The sun, and whatever remnants of Earth remain, may join them, forever severed from the luminous body of Milkomeda, condemned to solitude in the dark between clusters. If this fate comes to pass, our solar system will drift through silence, its white dwarf sun dimming, its planets frozen. No neighbor stars, no galactic disk, only emptiness in every direction. For billions of years it will wander alone. The memory of life, once blooming on its third world, will be carried across the void like a secret no one is left to tell. Another possibility is that the solar system remains within the merged galaxy, but in a transformed orbit. Instead of circling serenely in the galactic disk, it may be drawn into an elongated, looping path. Nights on Earth, if any surface remains, would no longer resemble the sky we know. Instead of a familiar band of the Milky Way, the heavens would blaze with tidal streams and strange constellations, remnants of the merger written across the sky. And then there is the faint but haunting possibility that the solar system will drift too near the galactic core, where the twin black holes spiral toward their final union. To be caught in such a tide would be annihilation. The sun would be torn from its planets, perhaps swallowed, perhaps flung into exile at unimaginable speed. The odds are small, but not zero. In the mathematics of collision, some stars always fall toward the monsters at the center. It is tempting to wonder, could life endure in some corner of this chaos? Perhaps not on Earth, doomed by the sun's evolution, but elsewhere, in younger planetary systems born in the starbursts of the collision. Gas clouds colliding will trigger the birth of new stars, and around them, new worlds. Some of these may form oceans, skies, perhaps even mines. The destruction of old galaxies may seed the conditions for life in new ones. If so, the merger of the Milky Way and Andromeda is not an ending, but a transformation, a death that gives rise to futures we cannot imagine. And yet for us, the fate of Earth is sealed. Long before Andromeda fills our sky, our oceans will have boiled, our continents scorched, our atmosphere lost. The biosphere will vanish. Perhaps life will leave Earth, carried by descendants who master the stars. Perhaps not. Either way, our planet will be reduced to a rock circling a dying sun, swept into whatever orbit the merger dictates. This is the paradox of cosmic perspective. To know our fragility is to feel despair, yet also awe. We are temporary, our world finite. but we are made of atoms forged in stars that lived and died before Earth existed. Those atoms will endure, carried into new orbits, new galaxies, perhaps even new worlds. The matter of Earth is eternal, even if its form is not. What then is the fate of Earth? To be consumed by the sun, or to wander as a frozen husk, to be ejected into solitude, or carried within the body of a new galaxy? In all cases, the answer is the same. Earth will not endure as we know it. Its life is fleeting, its destiny is to dissolve. And yet the story does not end in silence. For even in the death of Earth, the atoms that formed us will continue their journey. Our matter will remain passengers in the long voyage of the cosmos. Whether scattered into the void or gathered into a new world, we will continue, transformed, unknowing, but eternal in substance. The fate of the sun and earth is to vanish. The fate of their matter is to endure, and in that endurance lies a strange kind of immortality. The question is no longer whether our world survives. It does not. The question is, when the earth is gone and the sun a fading ember, will the story of life have found another stage? Will consciousness rise again in the firelit skies of the merger, or will the universe return to silence with no eyes left to see its strange beauty? When the violence of first contact has passed, when the arcs of stars have been torn into ribbons and the skies have burned with firestorms of newborn suns, the galaxies will begin to drift apart again. It will seem for a moment as though the danger has passed, that the Milky Way and Andromeda might part ways, leaving behind scars but retaining their separate forms. But appearances deceive. Gravity is patient. Like dancers after their first turn, they will circle back. Each pass will slow them, each encounter drawing them deeper into one another's embrace. And as they spiral toward union, a strange calm will descend. This calm is not peace in the human sense. It is not stillness. It is order emerging from chaos. In the aftermath of their violent encounters, the stars of both galaxies will find themselves in new orbits, their paths reshaped by the gravitational tides of collision. Some will be cast into elongated loops, others flung outward into tidal tails, others pulled inward toward the heart. But over time, the swarms will settle. The frenetic turbulence of the merger will relax into something quieter, slower, more stable. Imagine the Milky Way's disk, once so delicate and defined, its spiral arms winding gracefully around the core. That pattern will be gone. The arms stretched into ribbons, the disk thickened into a diffuse cloud. The sharp lines of the spiral dissolve into a swelling spheroid. Stars that once traced ordered circles will wander in looping, random paths. The choreography of a spiral gives way to the dance of a swarm. This transformation is not unique. Across the universe we see galaxies caught mid-merger, spirals shredded into streams, cores entwined. And then later, a final product. A great elliptical galaxy, vast and round, with no arms, no disk, no pattern but the smooth glow of countless stars. It is the fate of collisions, the end of spirals, the birth of ellipses. In this calm, something paradoxical happens. Though the galaxies merge violently, most stars remain untouched, their lives continuing across billions of years. Our sun, if it survives long enough, may drift into a new orbit around the merged core, indifferent to the cosmic ballet that reshaped its home. For stars, the merger is a rearrangement, not annihilation. It is only the delicate patterns, the arms, the disks, that vanish. The stars themselves endure. To stand on a surviving world during this calm would be to see a sky forever changed. The arcs and ribbons of tidal streams will fade, dispersed into the larger glow. The double cores, once looming side by side, will spiral closer until they blur into one. The sky will no longer blaze with firestorms of newborn stars. The frenzy will pass, leaving behind a quieter, redder sky. The galaxy's fuel for creation, their gas, will be consumed or expelled. Starbirth will slow, then cease. The night will grow dimmer, more serene. Yet serenity carries its own weight. An elliptical galaxy is quieter, but also older, redder, and colder. Without the spiral arms to compress gas into new stars, the burst of creation will fade. No new suns will replace those that die. The galaxy will glow with ancient stars, cooling and dimming across the aeons. The calm of star swarms is the calm of age. It is the beginning of galactic senescence. Still, the structure itself is magnificent. An elliptical galaxy born of merger can span hundreds of thousands of light years, containing trillions of stars. Its halo will be vast, its central bulge swollen, its outer reaches diffuse with the faint glow of ancient suns. From within, the sky would stretch in every direction, filled with stars more densely packed than any we have known. To look up from a world inside such a galaxy would be to see a night ablaze with light, not in arcs or spirals, but in every corner of the heavens. At the center of this calm swarm lies the ultimate convergence. The black holes at the heart of each galaxy will spiral inward, slowly at first, then faster, as they shed energy in gravitational waves. Their dance will last millions of years, their orbits shrinking until in a final instant they collide. The union of these titans will send ripples through space-time itself, waves of gravity racing outward at the speed of light. For a brief moment the universe will tremble. Then, silence. A single larger black hole will remain, anchoring the calm swarm of stars around it. This, then, is the strange fate of our home. The Milky Way will not end in fire, but in quiet transformation. Its spiral arms will vanish, its disk will dissolve, its stars will drift into calm, random swarms, circling a new, swollen heart. The galaxy will not be destroyed. It will be remade. For us, the knowledge of this fate is a revelation. It shows that destruction and creation are not opposites. They are phases of the same process. The chaos of collision gives way to the calm of swarms, the violence of merging births, the serenity of ellipses. What seems catastrophic is, on cosmic scales, a path to order. But calm is not eternity. Even this state will fade. Over trillions of years, stars will burn out, galaxies will dim, and the universe will grow cold. The calm of star swarms is only a chapter, not the end. And yet it is the end of the Milky Way and Andromeda as we know them. Their names, their forms, their identities will dissolve. What remains is something new, something greater, something inevitable. In the stillness after the storm, in the calm of star swarms, the universe reveals its truth, that permanence is an illusion and change is the only constant. The galaxies will merge, the swarms will settle, and the night sky will belong to a new creation. The question is, when the calm arrives and the stars drift in their final orbits, what memory will remain of the spirals that once were, and of the fleeting lives that gazed upward to wonder at them? When galaxies collide, our minds leap first to stars, the arcs of light torn into ribbons, the blazing bursts of new suns igniting from crashing gas clouds, the monstrous black holes circling toward union. But beneath the grandeur lies something smaller, quieter, and perhaps more haunting. The fate of worlds, planets. The tiny spheres where matter condenses into landscapes, seas, and skies. The fragile cradles where life might arise. For though stars rarely collide, planets are bound by delicate orbits. And when a galaxy is torn into chaos, those orbits can be broken. Worlds may be ripped away from their suns, set adrift in the void. Others may fall inward, consumed by their parent stars, or hurled outward, wandering eternally in the dark. The fate of galaxies is written in grandeur. The fate of worlds is written in silence. Most planetary systems will endure. The vastness of space ensures that direct destruction is rare. A sun may drift into a new orbit around the merged core, but its planets will likely remain bound to it, circling as they always have. Across the collision, billions of solar systems will continue serenely, their planets oblivious to the galactic chaos unfolding around them. For life, should it exist on those worlds, the collision might go unnoticed, save for the strange and shifting sky. But not all systems are so fortunate. Some stars will be drawn into tidal streams, their orbits stretched, their grip on their planets weakened. In these storms, worlds can be lost. A slight gravitational nudge is all it takes for a planet to slip free, exiled from its sun. Once unbound, it becomes a rogue, drifting through interstellar night, a frozen wanderer without warmth. Such planets may number in the billions after the collision, scattered like dark seeds into the void. Others may fall toward danger. Stars drawn inward toward the galaxy's core will carry their planets with them into regions dense with gravity. Some may be captured by other suns, ripped from their parent and enslaved by a stranger. Others may be torn apart entirely, pulled into black holes or shattered by tidal forces. A few may survive only to find themselves orbiting new masters in alien skies, their nights lit by unfamiliar constellations. And what of Earth? Its fate is uncertain. Long before the galaxies fully merge, our sun will swell into a red giant. Earth may be consumed, its surface scorched to vapor. If it survives that fire, it will orbit a white dwarf, frozen and lifeless. In the collision, the sun may be ejected from the galactic core, carrying Earth with it. Our world could wander forever in intergalactic dark, a silent relic of a species long vanished. Or it may remain bound within the new galaxy, circling in some distant halo orbit, its surface a frozen tomb. There is a darker possibility still. If the solar system drifts too close to another star during the merger, Earth could be stolen, its orbit broken, its path diverted. It might circle an alien sun, its history erased by capture. To imagine such a fate is to feel the fragility of everything we know, that our world, our sky, even our sun is not guaranteed. All of it is held together by balances delicate enough to be broken by a passing tide. Yet even in this haunting vision lies wonder. Rogue planets, cast adrift, may still carry warmth in their cores, heated by radioactive decay or tidal forces from captured moons. Beneath their frozen crusts, oceans might persist. Life could endure, hidden from the stars, carried into exile. The galaxy's destruction may scatter not only worlds, but seeds of possibility. Creation, in forms we cannot imagine, may follow in the wake of chaos. From a vantage far in the future, when the Milky Way and Andromeda have become one, the new galaxy will be filled not only with stars, but with wanderers, rogue planets, captured worlds, orphaned moons. A population of exiles, silent in the dark, carrying the memory of the collision. They will never shine, but they will endure, perhaps more numerous than stars themselves. This is the strange duality of galactic fate. For galaxies, collisions are not destruction, but transformation. For stars, survival is the norm. But for worlds, for the small, fragile spheres upon which everything that breathes depends, fate is crueler. Some will survive unchanged, others will be exiled, enslaved, or erased. And here lies the most haunting thought of all. Somewhere in Andromeda, perhaps even now, there may be another Earth. Another world with oceans, with forests, with minds that look upward in wonder. And when the galaxies collide, that Earth too will face the storm. Its fate, like ours, is fragile, uncertain, delicate against the tides of gravity. The collision is not only the fate of galaxies, it is the fate of worlds. The question then is not simply what becomes of stars, but what becomes of the homes they carry. What becomes of Earth? What becomes of any world where life looks to the sky? Will they endure the merger, or will they vanish, leaving no memory but silence? At the core of the Milky Way, a silent predator waits. Sagittarius, a star, 4 million times the mass of our sun, a shadow in space surrounded by stars that whip around it at incredible speeds. In Andromeda, another giant lurks far larger, perhaps 100 million suns compressed into a single abyss. For billions of years they have reigned unseen, the gravitational anchors of their galaxies. But destiny has always drawn them together. When the Milky Way and Andromeda finally fuse, it will be these two monsters who decide the final shape of the new creation. Their paths will not cross quickly. After the galaxy's first violent embrace, the two black holes will still be separated by tens of thousands of light years. Each will sit enthroned at the heart of its own core, surrounded by a storm of stars. But the physics of gravity allows no escape. The galaxies may drift apart after their first pass, but they are bound. Each time they swing back, the distance between their black holes shrinks. Slowly, inexorably, they spiral inward. As they draw closer, streams of matter are funneled into their hunger. Gas clouds torn apart by the collision will rain into their accretion disks, igniting quasars brighter than whole galaxies. To stand beneath such a sky would be to live under twin suns of annihilation, each black hole feeding, each blazing with the fury of infall. They will burn, then dim, then flare again, as though two cosmic beacons were signaling across the void. For billions of years this dance continues, until separation is measured not in thousands of light years, but in hundreds, then tens, then one. They will orbit each other like titans circling for a final strike, each pass releasing energy in gravitational waves. These waves ripple through the fabric of space-time itself, expanding outward at the speed of light, carrying with them the announcement of a cosmic union. Civilizations billions of light years away may one day detect them, faint tremors from the death spiral of the Milky Way and Andromeda. At last, in their final approach, the two black holes will circle each other at near light speed. Their horizons distort, space-time twisted into impossible shapes. Each orbit tightens, each loop shrinks, until in a final instant the horizons touch. Two become one.
The energy released in that moment defies comprehension. For a brief heartbeat of cosmic time, more energy is unleashed in gravitational waves than all the stars of the observable universe shining together. The universe itself will shudder, and then silence. A single black hole will remain spinning, swollen with the combined mass of both. It will sit at the center of a new galaxy, a monarch born of union, anchoring everything around it.
Astronomers have a name for that future galaxy, Milkomeda, an elliptical colossus formed from the wreckage of two spirals. Its shape will be round and diffuse, without arms, without the fragile beauty of spirals. It will be vast, perhaps 300,000 light-years across, containing trillions of stars. From within, the night sky will blaze with density, stars packed closer than anything we now imagine. The Milky Way's delicate band will be gone. In its place, every direction will glow. This transformation is not destruction, but renewal. Spirals vanish, but in their place rises something even grander. Where once there were two galaxies, there is now one, bound by a single heart. Milkomeda will be our new home, the galaxy that inherits both histories. The stars of Andromeda and the Milky Way, long separated by distance, will now share a destiny. Yet even in this triumph of union lies a shadow. Milkomeda will be redder, older, quieter. The bursts of star formation will fade as its gas is consumed or expelled. New suns will no longer replace the dying. In time, the galaxy will age, its brilliance dimming, its stars cooling, its skies reddening. The collision that births it will also seal its fate as an aging giant. Still, the moment of union will echo across eternity. The gravitational waves unleashed will race forever, etching the memory of the merger into the very fabric of reality. And within the new galaxy, the stars themselves will carry the scars, tidal tales of light, strange orbits, clusters adrift in the halo. The union of giants will leave its mark in every corner of the sky. For us who look upward now, the thought is staggering. To know that the faint smear of Andromeda is not simply a neighbor, but a future. That our galaxy is not eternal, but destined for transformation. That the heart of the Milky Way itself will one day be consumed by a greater darkness. And yet, in that consumption, a new galaxy will rise. The story of the Milky Way does not end with collapse, but with union. The story of Andromeda does not end with conquest, but with surrender. Together, they become something greater, something new, something inevitable. The question that lingers is this: when Milkomeda is born, will there be any eyes left to see it? Any minds left to wonder at the calm glow of a new galaxy, forged in silence, witnessed by none? When the Milky Way and Andromeda complete their long union, they will no longer be two spirals circling in the dark. They will be one, a single giant elliptical galaxy we call Milkomeda. But the story does not end there. For our cosmic neighborhood, the local group, contains more than 2 galaxies. There are dozens, and in the deep future, their fates too will be bound. The Triangulum Galaxy, a smaller spiral hovering near Andromeda, may already be caught in the same gravitational tide. Some models suggest it will spiral in long before the Milky Way and Andromeda finish their merger, plunging into the chaos of that collision. Others hint it may linger on the edges, only to be captured later, its own stars folded into the great elliptical body. Whether as a participant or a latecomer, Triangulum will not remain free. Its destiny lies within Milkomeda's embrace. Beyond these giants, the local group is dotted with dwarfs, tiny galaxies, dim clouds of stars held loosely together. Some orbit the Milky Way, others circle Andromeda, and still more drift between. Over billions of years, all will fall inward, swallowed by the growing mass of the central elliptical. Each will be torn apart, their stars scattered, their identities erased. The local group will be devoured by its own gravity. In the far future, what once was a family of galaxies spread across millions of light years will be one single vast structure, a supergalaxy containing all the light of the local group. The delicate separations, the beauty of neighbors seen against the void, will vanish. Where once the local group was a cluster, it will be one body, one structure, one fate. This might sound like expansion, a triumph of order, but in truth it is the opposite. For though our local group collapses inward, the greater universe expands outward. The space between clusters grows wider, faster, driven by dark energy. In 100 billion years, the local group will be alone. The rest of the cosmos will drift beyond our horizon, receding faster than light, lost to view forever. This is the paradox of the dark future. Locally, order grows. Gravity pulls together the scattered members of our group, forging unity from separation. Globally, order dissolves. The fabric of the universe stretches, scattering galaxies into isolation, breaking apart the great web of structure. What we gain in intimacy, we lose in connection. Imagine that far future sky. From within Milkomeda, the heavens would blaze with stars, denser, brighter, richer than the view we know. Triangulum stars, the dwarfs, all folded in, filling the night with a sea of suns. But look beyond, and there will be nothing. No faint smudge of Andromeda, no glow of Virgo cluster, no distant filaments, only darkness. The rest of the universe erased not by destruction, but by distance. Beyond the local group, everything will have vanished. The local group will become a cosmic island, a single elliptical galaxy adrift in a void that grows ever colder, ever emptier. The light of its stars will be all that remains, the only trace of a once crowded cosmos. For any beings who might exist in that epoch, the universe will appear far smaller than it truly is. They will see only their own galaxy. They may never know there was once a universe filled with billions more. This is perhaps the most haunting truth of all, that cosmic history has a window. We, living now, occupy a privileged moment. We can see Andromeda with the naked eye, We can map galaxies billions of light years away. We can glimpse the cosmic web in its full sprawling glory, but in the deep future, that window closes. The evidence of expansion will vanish. The universe will look static, eternal, a single island of stars floating in the dark. Astronomers of that distant age, if any endure, may never suspect the truth. They may never know of the Big Bang, of the billions of galaxies that once filled the void. To them, the cosmos may appear to be a single structure, infinite and unchanging. They will be trapped in an illusion born not of ignorance, but of time. The local group's fate, then, is both magnificent and tragic. Magnificent, because it will merge into a galaxy of unparalleled size and brilliance. Tragic, because in doing so, it will lose the universe. It will become a jewel, yes, but one locked in a box of infinite dark. And in that dark, even the jewel will fade. As fuel runs out, star formation will cease. Stars will age, redden, and die. Dwarfs will dissolve. Black holes will grow. Milkomeda will not remain young and brilliant forever. In time, it will dim. It will cool. It will fall silent. The union that began with fire will end with shadows. The dark future of the local group is not an apocalypse, but an inevitability. Everything falls inward, everything gathers, everything ends. And yet, to reflect on this fate is to feel a strange kind of awe. For we live in the fleeting moment between, the time when the local group still shines as many and the universe is still vast. We are here in the dawn, while the night is still full of light. To look upward now is to see not only beauty, but memory, a universe that will someday vanish from view. The question that lingers is this: what does it mean to witness the universe while it is still visible? To live in the brief age when the sky reveals its vastness before it contracts into silence? Is this coincidence, or are we in some deep way chosen by time itself to know the true scale of the cosmos before the window closes forever? Time moves differently when measured in the life of galaxies. For us, a century is vast. For stars, it is nothing. For galaxies, it is the blink of an eye. Yet even galaxies age, and in the far reaches of time, they too grow weary. After the fire of their youth, after the storm of mergers and the frenzy of star birth, comes a slower, darker age, the age of entropy. In the present universe, galaxies are alive with creation. Spirals blaze with newborn stars, blue and hot, ignited from clouds of gas and dust. Supernovae erupt, scattering elements into space. Black holes flare as they feed. The cosmos hums with energy. But this era is temporary. Gas is not infinite. The fuel of creation is consumed, and with each generation of stars, less remains. Billions of years after the Milky Way and Andromeda merge into Milkomeda, the frenzy of star formation will fade. The gas clouds that once gave birth to suns will be gone, swallowed into stars or expelled into the void. No new suns will replace the dying. The galaxy will redden, its light dominated by long-lived aging stars. The brilliant blue of youth will be gone. The spirals are already gone by then, erased in the merger. What remains is a swollen elliptical husk, its shape diffuse, its arms dissolved. In youth, galaxies are intricate, fragile, alive with pattern. In age, they are bloated, featureless, and red, a husk of what they once were. Across the universe, this transformation unfolds in silence. One by one, galaxies redden. One by one, they grow quiet. The brilliant spiral disks that now fill our telescopes vanish. The night sky becomes less diverse, less wild, more muted. It is the slow extinction of beauty, and yet for billions more years, starlight will continue. The stars that remain are small, long-lived, burning their fuel slowly. Red dwarfs may last for trillions of years, glowing faintly long after suns like ours are gone. Their light will sustain the cosmos through its middle age, but even they will not last forever. Entropy is relentless. It is the law that governs all things. Energy spreads, heat dissipates, order dissolves. The cosmos, for all its brilliance, is bound by this fate. It is not fire that ends it, but silence. As the galaxies grow older, as their stars age and die, black holes will reign. They will swallow the remnants of suns, the corpses of stars, the husks of planets. Gravity will tighten its grip, even as light grows weaker. Galaxies will dim, collapsing not in shape, but in spirit. No longer engines of creation, they will be mausoleums of what once was. This is the dark future of the cosmos, the end of starlight. To imagine it is to feel unease. We are creatures of light, bound to the sun, our days measured in brightness. For us, night is temporary, and morning always follows. But in the universe's future, morning will not return. The dawn of stars will end. Darkness will claim the skies, not for hours, but forever. Even so, entropy is not annihilation. It is transformation. The elements forged in stars will remain. The atoms that once burned with light will still exist, scattered across space. Hydrogen fused into helium, helium into carbon, carbon into iron. The chemistry of life will be preserved in matter, even as its structures collapse. The story ends not with disappearance, but with dispersal. For the Milky Way, for Andromeda, for Milkomeda, this fate is shared. Once bright, then swollen, then silent. Once spirals, then ellipses, then husks. Once full of fire, then only shadows. The arc is inevitable. The universe writes it not in catastrophe, but in exhaustion. And yet within this exhaustion lies a paradoxical beauty. To know that the cosmos itself will grow quiet is to feel the value of the present. We live in the age of starlight. We walk beneath skies filled with fire. We see galaxies while they still blaze with youth. We exist in a universe not yet tired, still alive, still wild. We are here in the brilliance, before the silence descends. The question then is not whether the universe ends in entropy. It will. The question is, what will life do with its moment of light? Will it leave a trace, carry the flame into the long silence, or vanish unnoticed, leaving the cosmos to cool alone? When we speak of galaxies colliding, of stars hurled into chaos, of black holes circling in their last embrace, it feels distant, too vast to touch our lives, too slow to matter. Billions of years is longer than the lifespan of the Earth, longer than the span of our Sun. Humanity will almost certainly not be here to see the Milky Way and Andromeda draw together in the sky. The collision is a story for a cosmos older than our species can comprehend, and yet we are not absent from it. Even if humanity vanishes tomorrow, even if Earth itself burns away when the sun swells into its red giant form, we remain passengers in this grand procession. For every atom of our bodies, every particle of our bones and breath was forged in stars. The carbon in our cells was born in the fire of suns that lived and died long before the Earth itself formed. The iron in our blood was cast into being in supernova that exploded across ancient space. We are not separate from the galaxy's fate. We are its children. We are its echo. When the galaxies collide, our matter will be there, scattered perhaps, dissolved into soil or stone, drawn into the sun, or carried out into the dark on comets and dust. But still there, still part of the Milky Way, still drawn into the union with Andromeda. Long after humanity is gone, long after memory itself has faded, our atoms will continue the journey. We belong not only to Earth, but to the galaxy. This truth reframes the collision. It is not merely an event we will miss. It is an event we will join. We will not survive to see it with eyes, but our matter will move with it. The same way that the stars endure, so do the atoms we carry. They are ancient. They are patient. They will outlast us, and in doing so, they will bear us forward into the future we cannot touch. What does it mean then to belong to a galaxy with a destiny? It means that our lives, brief though they are strands in a far greater tapestry. It means that we are not fleeting anomalies, but continuations of a story written in hydrogen and starlight. Our choices, our civilizations, our questions may vanish, but our matter will remain bound to the fate of the cosmos. We are temporary forms in an eternal process, and perhaps, just perhaps, humanity will not vanish entirely. Perhaps in some distant epoch our descendants, or the beings who inherit from us, will survive to witness the collision. They may live on worlds orbiting distant stars, scattered across the galaxy, perhaps even across both galaxies. For them, Andromeda's slow approach may be a sky-long prophecy, unfolding over millennia. To look upward and see another galaxy swelling, brighter with each passing age, would be to feel destiny not as abstraction, but as presence. The collision would be not theory, but sight. And if no one survives, if humanity's thread ends before that era, the question shifts. Does the meaning of the collision vanish without witnesses? Or does meaning endure, even if unseen? The galaxies will merge whether we are there to name it or not. The stars will spiral, the black holes will unite, the local group will collapse into silence. The universe is not contingent upon our eyes, but our eyes, while they last, are its mirror. To reflect on this future is to find our place not at the center of the story, but as a fleeting awareness within it. Perhaps that is enough. To know that we live in a galaxy bound to collide, to know that our atoms will be carried into that future, to know that for a brief time, on a small world, a species looked upward and wondered what it meant to belong. It is humbling, it is terrifying, but it is also profoundly beautiful. For in the grand arc of billions of years, our lives are moments, and yet they are moments that can imagine eternity. The stars cannot reflect, the galaxies cannot ask, but we can. And in asking, we become part of the story in a way matter alone cannot. We become the voice of the galaxy, whispering its destiny before it arrives. One day, Milkomeda will exist. Whether humanity endures to see it or not, our essence will be there. Our atoms will have crossed into that new creation, folded into its stars, its dust, its silence. Our place in the collision is not uncertain. It is written, we belong. And so the question lingers, is belonging enough? Or does it call us while we still live to act as custodians of the light? To preserve memory, to carry forward meaning, to leave a trace for the silence to inherit. How can something be a neighbor and a destiny at the same time? That was the question we began with, gazing at the faint smudge of Andromeda in our northern sky. To the eye, it seems fragile, a blur of light, smaller than the moon. To the mind, it becomes immense, a spiral of 1 trillion suns. And to the future, it is everything. We are children of the Milky Way, born of its stars, shaped by its gravity, sustained by its light. But the Milky Way itself is not permanent. It is bound in motion, drawn inexorably toward Andromeda. Their paths are written in the geometry of the cosmos. The future of our galaxy is not solitude, it is merger. And what does that mean for us? It means that our home is not static, but evolving. It means that the stars we see tonight will not always be where they are. That the constellations of myth and memory will one day be erased, replaced by a new sky we can scarcely imagine. It means that to belong to a galaxy is to belong to change. The universe does not give us permanence, it gives us transformation. Mountains rise and fall, planets ignite and fade, galaxies collide and merge. Even atoms are forged, broken and reforged. And yet, in this endless cycle of collision and renewal, there is something deeper than permanence. There is continuity. We are part of a chain that stretches from the first stars to the last, from the Milky Way's youth to Andromeda's embrace. Andromeda is not simply another galaxy, it is our reflection, it is our fate. In a few billion years, its stars will blaze beside ours, its dust will mingle with ours, its black hole will spiral into union with our own. The collision will not destroy us. It will transform us. Two become one. Milkomeda, vast and silent, will rise from the wreckage. We began with a riddle. We end with an answer of sorts, that the cosmos does not whisper in stability, it roars in destiny. To live in a universe like this is to accept that nothing endures unchanged. But it is also to know that change itself is the story, that transformation is the language of the stars. So the next time you look upward, find the faint blur of Andromeda. Know that it is not a stranger. It is your future. It is your inheritance. It is the mirror in which the Milky Way sees its destiny. And it is the reminder that the universe is not still. It is alive. It is restless. It is becoming. The cosmos does not give us permanence. It gives us collision. It gives us transformation. It gives us awe. And if you listen closely, not with ears, but with imagination, you may hear it. Not a whisper, not a murmur, but a roar. The roar of destiny echoing across billions of years, carrying us forward into the riddle of Andromeda. And so the faint smear of Andromeda hanging in our sky is not merely a neighbor, it is our future. We are children of the Milky Way, bound to merge, carried into a destiny written in gravity itself. The universe does not gift us permanence, it gives us transformation. Stars are born and die, galaxies collide and renew, and we, brief witnesses, are swept along in the tide. The cosmos does not whisper, it roars, and its roar is the sound of destiny unfolding in the dark. Thank you for joining us on this extraordinary journey through the universe here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us, where we unravel the darkest mysteries of space.